So let's say we have to describe categorical data now. In the last class, in the last video, basically we have seen about different scales of measurement. And we have seen about scales of measurement because we had to draw summaries from the data. So in order to draw it or graphical numerical summaries, we needed scales of measurement. Now let's understand graphical summaries of categorical data. In next video, we'll understand it about numerical data. So for categorical data, one of the most easiest thing to do is to put it in a table. For example, if let's say there's some ordinal kind of data, ordinal which again is a scale of measurement for categorical kind of data which has a particular order between the different categories. So let's say we have received reviews of a product and we have got so over here he stands for excellent, G stands for good, B stands for bad, and like this we have got so many like that. So let's just say this is the data that is given. Now if we have to organize this, what we can do is we can construct a table. So we can construct a table and let's just say this is the category, this is the count. So we have three categories, E, G and B, and we can usually count it using tally marks. So whenever we see an E, 1 G, 1 B, another E, another G, another B, another two E's, two G's, one B. So if, for example, if we had another E, let's just say, then that means this will make it 5. So this is not a count but actually a tally mark. And besides, we can just write the count as 5, 4 and 3. And we can write the total over here. So total is the number of entries we have taken for this review. Total is the count of all of these things, right? So 5, 6, 7, 8, 9, 10, 11, 12. So total is 12. So this is how we have organized it in the form of a table. What we can do additionally is find relative frequency. So all of these are frequencies. That means 5 out of 12 have given E, has given a rating E. So we can find a relative frequency as 5 out of 12. So relative frequency is nothing but frequency of that particular category divided by the frequency, sum of frequencies of all the categories. So that we have calculated it to be 12. So frequency of E is 5, frequency of G is 4, frequency of B is 3. So, and sum of all those frequencies is 12. So now for to find relative frequency, we have to just take this frequency and divide it by 12, this frequency and divide it by 12, and then we can find which one has the highest frequency. It is very evident that this has the highest frequency, followed by G, followed by B. So this is how we can summarize. This is in order to draw summaries from the data, right? Descriptive summaries from the data. That means we are just performing descriptive statistics. Again, in the last video, we have seen about different kinds of statistics. So we are drawing summaries from the data, and we are basically drawing descriptive summaries from the data. So using this table, we have found what relative frequencies. Now another thing that we can do is we can use charts. So table is usually used when there's like large kinds of data, not when there's like only 12 kinds of data. Let's just say there's some 1200 reviews that we have received and we wanted to tabulate it. Then table is a good way of doing it. You can do it in Google Sheets or Microsoft Excel. And another way, if we have fewer amounts of data, like for example, this can be population, a part of it we can take it as a sample which is representative of this population, and then we can do charts on it in order to draw summaries from the data, in order to perform descriptive statistics of the data. So charts are of two types. We have bar graph, we have pie chart. So bar graph is just like something that represents the frequencies. Let's just take the same example. So E we had 5, G we had 4, B we had 3, right? So this is a bar graph. We don't really draw these lines, but this is how a bar graph typically looks like, and it should start from 0 and 1, 2, 3, 4, 5. So this is how a bar chart looks. We have to again label the axis, x-axis and y-axis. X is the reviews, y is the frequency of them, and we can compare it like this. This is very easy. And if we have something like ordinal kind of data which we had over here, we basically use a model like we go from E to B. So this is first, second, and third, as we have discussed about ordinal scale of measurement in the previous video again. So because this is ordinal, there's some order. For example, if there was no order, if there was just some normal kind of data, if we just had cities and population, then we can arrange them in whatever cities and draw the graphs of population like that in whatever order. But if we have ordinal, we basically prefer to write it in one particular order. And even if we arrange this in ascending or descending order, whatever data, even if this population, if we arranged it in ascending or descending order, then we call it a Pareto chart. So a Pareto chart is basically something that's either descending or something that's either ascending, right? So that looks like this. So it's basically ordered. So it's sorted so that we can see a decreasing trend and an increasing trend, and this is basically used so as to simplify things. So if it is decreasing, we can find what's the city with the highest population very easily. If it is increasing, then we can find what's the city with the lowest population very easily. So that is what a Pareto chart will do. That's a Pareto chart. And then we have pie chart. So pie chart is usually something that is used to tabulate relative frequency. So we have different relative frequencies. We had 5 by 12, 4 by 12, 3 by 12 for E, G, and B respectively. So then what we do is that we represent this as proportions of a pie like this 1, 2, and 3. So this can be E, G, and B, and this angle that they make at the center of the circle, at the center of this pie chart, this angle will be equal to the relative frequency multiplied by 360 degrees, because the total angle is 360 degrees. Now this relative frequency again is only going to lie between 0 and 1. That's just understood. And then basically we have this pie chart to represent relative frequencies and compare proportions. So we can say E is greater than G and G is greater than B just by looking at a pie chart. So that was about charts, bar graph, and pie chart. And later we have to understand best practices that one must employ while doing all these graphing techniques. For bar graph, we can just say that whenever you draw a bar graph, you have to make sure that you label the axis, the x-axis and y-axis, so that you say what they represent. If you do it on a graph paper, you're supposed to write down the scale. What does 1 unit represent? Is it 1 centimeter or something like that? You have to always start from 0. If, for example, if over here from 0, if you have to go to 100, you can do it whatever way you want on this y-axis, but you cannot really write 5 over here and 100 over here. That's going to be wrong. You can start from 0 and you can indicate a y-axis break. So if it doesn't start from 0, then that is known as a truncated chart, which is an error in the chart. So that will be considered as an error. That's not a proper chart. So we basically should start from 0. If there's a case where you can't really write all numbers from 0 to 100, or let's say 0 to 1000, but you have to go to 1000. For example, if it's population, then population is always in lakhs, right? Population of city will be in lakhs. Now you can't really go from 0, right, 1, 2, 3 up to lakhs and then start from there. Then you can just indicate y-axis break like this, and from 0 you can just go to 1 lakh and just represent it, so on and so forth. So, and another thing to remember is that of the area principle. In a bar graph, the area that each slice or each the width of the bar graph and the height of the bar graph, the area of this should correspond to the amount of data it represents. For example, I can't have E to be of a greater width than G. This is not correct. Everything should be of the uniform width, and they should represent only the amounts that they represent in the original data. Now that is important. And in pie chart, we basically, whenever we draw a pie chart in Google Sheets or in Microsoft Excel, there are ways in which we can just represent these pies at a distance from the center. So that's usually not advised to do so, because we want to see what our proportions are with respect to the whole. So it's basically, if the distance from center of the slice is 0, then that's basically what is preferred. But if you have to If you are in a situation where you have to really show that, then it's okay, then you can just show it that way. For example, you can just take a part and then show that this is a slice of this pie chart. So then that was about pie chart and that was about bar graph. Another thing is about round of errors. Whenever you get a pie chart, you have to make sure that they add up to 100%. So whatever percentage is there, let's say this is 36%, 18%, 10%, or whatever percent is there, they should always add up to 100%. So that's very important. So this was about describing categorical data. We have seen about how when we have large quantities of data, we can use a table to describe it, and how we can use two different kinds of chart, that is a bar graph and a pie chart, to describe it. And then we have seen about organized bar graph, which is a Pareto chart, and then we have seen about pie chart, what are the best practices, what are the things that could normally go wrong. And now let's come to descriptive measures. So descriptive measures usually include measures of central tendency, which basically represent what is the centermost value. So when it comes to categorical data, we can usually have two main measures of central tendency, that is mode and median. Mode is something that you can apply to both nominal as well as ordinal kind of data, whereas median is something that you only apply to an ordinal data, because then we can order it in some way and then find a middlemost value of it. If it is not ordered, then finding the middlemost value will make no sense. If there's no order, in fact, then finding the middlemost value will not make any sense. So mode is the one which has the highest frequency. So this one will be highest frequency and hence highest relative frequency. They might be cases when the data might be bimodal or trimodal, which means it has two categories which have the same highest frequency, or it can have three categories which have the same highest frequency. For example, if you have E, G, and F, that is excellent, good, and bad, with a rating of with like maybe seven people have given a rating of excellent, six people have given a rating of good, five people have given a rating of bad, then that means the highest frequency is that of 7. So 7 is the mode of this data. And then this is an ordinal kind of data that I'm talking about. You can also do this in nominal kind of data, there's no difference. But if it was 7, 7, and 5, then that means these both are the mode of of that data, so both excellent and good. But if it was 7 and 7 and 7, then that means all three of them are the mode of that data. So we'll basically take this and understand the median, because this is an ordinal kind of data. I've ordered it again, excellent, good, and medium. And if I have to find a median, so you have to find a total number of observations. So over here it was 12, which was even. So if n is even, then the n by second term as well as n by second plus 1 term, both it has two medians, both are the medians. So over here n by second is the sixth term, n by second plus 1 term is the seventh term. Over here 6 and 7 are both excellent, so the median is excellent. Whereas if n is odd, then the median is n plus 1 by second term, not the n plus 1 by second value, but the term which corresponds to uh, that that place in that order. If you arrange, for example, this is 5. Okay, let's just take this 9. So if there were 9 observations, then this value will be 5. So that means this item which corresponds to that value, the fifth item, will be the median of that data. So this was all for today. We have seen about how to describe categorical data. We have seen about charts, graphical representation basically in tables and charts, bar graph and pie chart, and whatever the mistakes there are, the best practices that one must employ. And then we have seen about kind of numerical summaries by employing descriptive measures and measures of central tendency, of mode and median for the categorical data.